Oxygen difluoride is a molecular formula. In this compound, we have 1 oxygen, 2 fluorines. I'm going to do a tally of the valence electrons that are available in this compound. Oxygen difluoride. Well, in oxygen difluoride, there's 1 oxygen atom. Here it is in the periodic table, the simplified periodic table. And then there are 2 fluorine atoms. Well, the fluorine is located right there. Notice that oxygen is in group 6A. So for every oxygen, there are 6 valence electrons. Fluorine is in group 7A. So for every fluorine, there are 7 valence electrons. Again, with oxygen difluoride using a regular periodic table, there is an oxygen located here and a fluorine located in group 7A. So oxygen is found in group 6A, fluorine is found in group 7A. So oxygen has 6 valence electrons, fluorine has 7 valence electrons. Tallying the valence electrons available in oxygen difluoride, there is 1 oxygen atom. Each oxygen atom brings 6 valence electrons. There are 2 fluorine atoms. Each fluorine atom brings 7 valence electrons. So that's a total of, well, 1 times 6 is 6, 2 times 7 is 14, 6 and 14 is 20. There are 20 valence electrons available for bonding. Well, I put the oxygen down as the central atom. It's appearing first in the formula. So there's my oxygen. And I'm going to put the fluorines down around the central atom. Next, I'm going to connect the fluorine to the oxygen with a single bond that represents the sharing of 1 pair of electrons. So I'll just draw my electrons here. Each of the little dots represents an electron. So that would be a bond showing 2 electrons. And here's another 2 dots for another 2 electrons. So now I have to make the outside atoms happy. Well, each fluorine wants to have 8 valence electrons around it, or 8 electrons around it. This fluorine sees 2, wants 8, so it needs 6 more. So I'm going to give it 6 more. This fluorine, same deal. Sees 2, wants 8, needs 6 more. So I'm going to give it 6 more. Now, each of the fluorines is happy. Each fluorine has 2, 4, 6, 8 electrons around it. 2, 4, 6, 8 electrons around it. But now I need to make the oxygen happy, the central atom. Leave that till the end when you're doing these. So now, the oxygen sees a total of 4 valence electrons. It needs to have 8, so you have to give it 4 more. So I'm going to do that. So now the oxygen sees 8 valence electrons. It's happy. The fluorines are all happy. Well, how many dots do I have down here? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, counting the 2 non-bonding pairs of electrons. So I have 20 electrons down here, and once again, this is a happy electron dot diagram.